Hello, this is a quick demo for the Solana hackathon for Zeroclaw plugin that sends over a couple USDC on DevNet. Let's start right away with instructing the agent to do something. In this case, we tell him to extract the signer public key on this in a couple minutes and send over 5 USDC to a particular address. The extracting of the signer public key is special because our plugin does not have access to private keys at all. Instead, it connects to a vault in the backend, a HashiCorp vault, and that takes care of signing and maintains the private key. So our agent has no access to the private key at all. So now it's figuring out what the public key is for that address. It holds 10 USDC and sends over USDC to that address. It needs to figure out a couple things of the associated token accounts, and I'm using a particularly slow LLM actually. Next step is to create a Solana transaction. The transaction is produced through SPL, basically an IDL that describes the SPL token transfer. It simulates that. From the simulation, it extracts the changes in balances and it checks the changes in the balances against a configuration that allows a certain amount of changes at most. And as you can see, this went through. You can go here and see this is a DevNet. See this transaction. Oop. It's over here. 5 USDC to my address. So what's so special about this plugin? Real quick, our agent never has access to the private key. That is quite obviously, we want to pay people, we want to have access to funding, but we want to have extra layer of protection for our funds so that an agent that maybe asks the wrong LLM comes back with malicious intent and moves all of our money away. So how is our plugin constructed? We actually have 2 plugins. There's a plugin that constructs our transaction. This is compatible with an IDL from Anchor and can load the IDL from the blockchain, from a JSON blob in the config, or from a file. It takes care of simulating checks whether the configurations and thresholds are met. That's like policy enforcement. And the other part of the plugin is a separate plugin is called Keychain Sign, which talks to different backends, in our case HashiCorp's Vault, to take care of the transaction signing. So this is, as I mentioned, we are simulating, figuring out what is the change our transaction causes and run our policies against that. Secondly, we have a signer backend implemented currently, fully implemented. This is the Vault, HashiCorp Vault transit. There are stubs for 2 more, and we can extend this even further. It's quite easy to build anything in there. Now, as I said, there's a balance diff for each mint or token, basically. There's also some instructions or changes that are not allowed to take place. For instance, you cannot approve an SPL delegation. And then there's, of course, a hard-coded list of things that are accepted, like programs being called, instructions being called, recipients being, used. Lastly, here's a quick introduction how to install this. We are delivering a full quick start markdown to get to the state where you can actually right away talk to the agent and get something signed, including a Docker compose that spins up the vault in the background that's taking care of the transaction signing, and also initializing the vault. So this step basically gives you the public key that can be managed by the agent without the agent having access to the private keys. Thank you.